Welcome to Maths and Science by IITian channel. In this lecture, in continuation of my lectures on simultaneous equation solutions, I will be doing a numerical on finding the number of solutions in the given set of simultaneous equations. The equations can be consistent with unique solution, they can be consistent with infinite solutions, and the system of simultaneous equations can be inconsistent without a solution. Now we have to find out the behavior, whether there is a solution for these equations, or if there is a solution, whether it is a unique solution or whether it is infinite number of solutions. We have to find the number of solutions if solution exists. First we have to see whether solution exists or doesn't exist. For that we have to do the row and column elementary operations and reduce these simultaneous equations matrix into Euclidean form. We have to form the coefficient matrix separately, variable matrix separately, and constant matrix separately. And we make an augmented matrix of all these and try to solve the simultaneous equations. This process is very important. I have taken a very typical example. Process is very important. Process is easy to understand, but only thing is that you have to follow the step-by-step procedure. Please see this video till the end to understand fully the step-by-step procedure. Once you follow the step-by-step procedure, you will be able to answer the questions given. In JEE Advanced, there can be multiple answer questions. In JEE Mains, there can be single answer question. In Maths Olympiad, there can be a question asking for the behavior of the simultaneous equations. For everything, here is the solution. Let's go for it. Now let us write the question. We have to know the behavior of simultaneous equations What are the simultaneous equations given? First equation is 2x minus 7y plus 8z is equal to 31. Is it correct? 2x minus 7y plus 8z is equal to 31. 4x plus 9y, second one is 4x plus 9y minus 13z is equal to 42. Next one is 6x plus 2y minus 5z is equal to 74. These are the three simultaneous equations given to me. And what are the number of variables? Equations is equal to 3. Number of variables are x, y, z, that is equal to n is equal to 3, x is a variable, y is a variable, z is a variable. If number of equations are equal to number of variables, it doesn't mean that the given simultaneous equation produces a solution. No. It may be possible that there is no solution. It may be possible that there are no infinite solutions. It may be possible that there is a unique solution. For that, a procedure is to be followed. What is the variable matrix? Variable matrix is a column matrix X, Y and Z. Please follow the steps. What is the coefficient matrix? We will call it as A, coefficient. Coefficient of X, it is a 3 by 3 matrix. 2 minus 7, first row is 8, 2 minus 7, 8, 4, 9 minus 13, 4, 9 minus 13, third row is 6, 2 minus 5. What is the constants matrix? We will call it as B. On the right hand side, these are the constants 31, 42, 74. It is a column matrix. 31, 72, 31, 42, 74. In which form they are represented? The simultaneous equations can be represented in this form. A x is equal to b. This is the original given matrix. Now, we have to write the augmented matrix. What is augmented matrix? We will put a line between quotient matrix and the values of quotient matrix and constant matrix, and we will club both of them. Augmented matrix, let it be K, that is equal to, this will be a bigger matrix, 2 minus 7, 8, 2 minus 7, 8, and we will draw a line, dotted line, 31 in the first row, and 4, 9 minus 13, and 42 in the second row, and 6, 2 minus 5, and 74 in the third row. Now, this is augmented matrix. Okay. Now, we will perform the elementary row and column operations. This is the first step. First, make the initially from the simultaneous equations, make the coefficient matrix, variable matrix, and then your constant matrix. Then we will go for the augmented matrix. This is the first important step. Next step is operate row and column elementary operations on augmented matrix. This I have already explained you in various lectures on vectors. Please refer to them. How to do the elementary operations. To bring it to echelon form, or we can say IR 000 form. We will try our level best if we can bring. Let us go. in the process, first what we have to do? Make the first column elements below the first row element as zeros. IR is nothing but 1 0 0 0 1 0 0 0 1 form. Echelon form means. That means first element should be unity in I, and second element in the first column, third element in the first column should be zeros. That should be our target. Now, the same operation is to be done on the constant matrix also. Initially we have to do it we have to concentrate on the quotient matrix and bring it to that form. Automatically when operations are done on the constant matrix also simultaneously, its form also gets reduced to IR. Let us see what happens in this particular example. My matrix is 2 minus 7 8. 2 minus 7 8. I am going slow so that I am explaining. We cannot neglect even a single step. 2 minus 7 8 31. 4 9 minus 13 42. 6 2 minus 5. We cannot afford to make error also. 74. Now what is our target? With row operations, we want to make this as 0 and this as 0. Let us try. What happens? This 2 into 4, 2 is 4, 2 into 3 is 6. So that whenever you are operating with the row, that row will not change. We are operating with R1. Here we will write R2 minus 2R1. 2 into 2, 4 minus 4. And here we will write R3 minus 3R1. These two operations we will do and we will see the result. Two 0 0. First row will not change even for the augmented matrix. And second row will change, minus 2R1. 9 minus 2 into 7. What happens? 14. 9 plus 14, it becomes 23. These operations I have explained in my previous videos. Please see them. It's a very simple operation. Now, minus 13 R2 minus 2 into 8, minus 16. This becomes minus 29. And 42. 42 minus 2 into 31. That is 42 minus 62. That is minus 20. Now, third row will come. R3 minus 3R1. R3 is 6. 6 minus 3 into 2 is 6. 6 minus 6 is 0. In this second row, 2 minus R3 is 2. 2 minus 3 into minus 7. 2 minus 3 into minus 7 is plus 23. Then R3 minus 3R1. R3 is minus 5. Minus 3 into R1 is 24. Minus 3 minus 5 minus 24 is minus 29. And here you see 74 minus 3R1. 74 minus 3 into 31. 3 into 31 is 93. 74 minus 93 is minus 19. This is the augmented matrix. Now, what I have to do? I have to make this as 0. To make this as 0, I have to operate the second row, and because it is also 23, it is also 23. I have to make it as 0. For that, R3 minus R2. When I operate R3 minus R2, what happens? Let us see. What happens? I am not operating on R1. I am not operating on R2 because I am operating with R2. I am not operating on R2. On and with are different. So that my R1 remains same, my R2 also remains same, and my R3 will change. 23 minus 23. This 0 is 0. 0 minus 0 is 0. 23 minus 23 is 0. Minus 29 minus 29 is 0. And minus 19 minus 20. That means plus 20 minus 19, that is 1. This is simple arithmetics. Now, the answer is, what we have got is K dash is equal to, after elementary operations, it is reduced to 200 minus 7, 8, 23 minus 29, 00, 31 minus 21. Now, you tell me what is the rank. In the coefficient matrix, this is the portion only has non-zero elements, whereas this row is totally eliminated because all elements are 0. Only in I am talking about coefficient matrix. I am talking about only this matrix, coefficient matrix. I am not taking augmented matrix into consideration. All elements are 0. Regarding the definition of rank, you please refer to my earlier lecture. What is the rank of this? This implies coefficient matrix rank of A is equal to 2. Only 2 rows and 2 columns. One row is totally eliminated. Hence, rank is 2. If second row is also eliminated, then we can say rank is 1. If all the rows become 0, then we can say rank is 0. Now, for the whole augmented matrix, for this whole augmented matrix, this is the augmented matrix. The third row is not, all elements are not 0. For augmented matrix, all elements of third row are not 0 because 1 is there existing, 0, 0, 0, 1. Hence, rank of the augmented matrix is rank of augmented matrix is equal to R dash. Okay, that is R dash, that is 3. Because none of the rows or elements are fully 0 for an augmented matrix. If you want, I will write it again. Augmented matrix K dash is equal to, you please understand this very carefully, it is after elementary operations. 31 minus 20 and 1. 0, 23 minus 29. 0, 0, 0. This for all elements are 0 for coefficient matrix, but not for augmented matrix. Hence, augmented matrix rank is 3 and coefficient matrix rank is 2. That means R is equal to 2, R dash is equal to 3, which implies R is not equal to R dash. When this is the situation, in this case, please recollect from the previous video, please see the previous video on this chapter. Please see the previous video where we have conclusions I have written clearly. Here it implies inconsistent and no solution. Even though there are 3 equations and 3 variables, it has no solutions, because number of variables n is equal to 3, whereas r is equal to 2. The system is inconsistent and it has no solutions. Answers will be very tricky in this question. Answers will be, it will be written no solution but consistent. Here alternatives in the JEE examination or JEE mains or in IOQM or anywhere in mathematics, higher mathematics examinations, alternatives will be like this. Objective alternatives. 1. Find correct one. 1. System consistent, no solution. 2. System non-consistent but infinite solutions. System consistent with unique solution. System non-consistent with no solution. Now you tell me, after doing all this, what will be your correct answer? Your correct answer will be 4. There will be a tussle between system consistent, no solution, system non-consistent with no solution. In both the A and D, there is no solution is there, because if you find determinant, the determinant will be 0. That only indicates about the no solution. But whether system is consistent or not, that can only be found out from rank of the matrix. That is the importance of the rank of the matrix. Let us write here, if determinant is equal to 0, it can say no solutions. If rank of the matrix is less than n, it says inconsistent. For your benefit, I am going to write all the three conditions here, how to find the behavior of a simultaneous equation. It is very, very important. We should not read half and say that the system is consistent, non-consistent, system is having solution, not having solution. We should little bit stretch ourselves to know about system's consistency also. I think once we know system is consistent or non-consistent, and also system has solutions or unique solution or no solutions, then we will be confident enough to answer the given questions in the examination. If the conclusions, it is very important, I have explained them even in previous lecture. I took about 2 minutes for that and explained in detail. However, I am giving the brief. First conclusion is that if R is not equal to R dash, then system is inconsistent and no solution. This inconsistency cannot be found out from the determinant. Please try to understand. Second, if R is equal to R dash, then number of variables come into picture. If R is equal to R dash and equal to number of variables, then system is consistent and unique solution. Third, if R is equal to R dash, but the rank is less than the number of variables, then system is consistent but infinite solutions. With infinite solutions. In our particular problem, R is equal to 3 and R dash is equal to 2. It means system is inconsistent and the simultaneous equations, they have no solution. This is the answer. Please take care this particular rank, so that if you know how to find out the rank, for practice you can make number of matrices, take number of matrices and try to find out the rank. And try to find out for the simultaneous equations whether there is a solution. Don't stop only finding the solution. Try to find out whether system is inconsistent or consistent. With this, I want to stop this lecture, and if there is a value addition to you because of this lecture, please share my videos and channel and subscribe to my channel Maths and Science by IITian. This type of questions which are critical for JEE Advanced, Maths Olympiad and JEE Mains, I will be going on giving as and when I complete the syllabus. At present, we are in linear algebra. We are taking care of the linear algebra. For vectors, we have already completed major portion. For vectors, please refer to my earlier lectures, and in linear algebra also matrices, simultaneous equations, trace of the matrix and determinant of the matrix, 12 types of matrices, everything is discussed in the previous lectures. Please see them, comment on them, and please comment for any queries. Best of luck to everybody. Thank you for viewing my lecture. Best of luck.